Good morning, and thank you all for joining us for the presentation Designing Commercial PV Projects, brought to you by AEE Solar. Before we begin, if you're experiencing any technical difficulties, please notify me by typing your question in the question pane of the control panel on the right-hand side of your screen, and go ahead and click Send. We will be having a question and answer session following the presentation. You are welcome to submit your questions at any point during the webinar, and we will do our best to answer as many possible questions after the presentation. There will be a brief survey that will pop up in a new window immediately following the webinar. If you could please take a couple of minutes to complete the survey, we will go ahead and get you a copy of the presentation. At this time, I don't see any questions, so I'd like to go ahead and introduce our presenter today, Glenn Hall, AEE Solar's very own applications engineer. Glenn, I'm passing the presentation over to you.
Thank you, Caitlin. Welcome to today's webinar. As she mentioned, my name is Glenn. I've spent the past 5 years working at AEE Solar as an applications engineer, mostly with grid tie and commercial PV projects. And today we're going to be talking about trends that we're seeing in the industry for commercial PV systems. Quite a lot has happened, as you know, over the past 12 months. And as we roll into the second half of the year, we are seeing a big increase in business of people planning for commercial projects for the second half of the year. So based upon these insights from our customers, our network of installers, and our suppliers, we're going to offer our insights on commercial PV systems. And so questions are during the presentation, please hold them till the end, as we got a lot to go over. Okay, so discussion topics that we will be talking about today. We're seeing 60 cell versus 72 cell modules and considerations for which ones to choose for your commercial PV projects going in through the rest of the year. We're going to talk about trends and developments for commercial PV systems and sizing of the inverters, and also considering the optimal tilt of arrays on commercial projects. A big concern rolling into the second half of the year, and especially for January 1st, 2019, as we end this year going into the next one, we'll be preparing for module level rapid shutdown requirements as required by NEC 2017 on states that are adopting or are on that code cycle. We're also going to be looking at ballasted systems and any trends that we notice there to ease and speed your installations and lower your installed costs for you and your customers. Specifically, we'll be looking at the Aero Compact ballasted racking system. We're going to look at maximizing the output of ballasted systems on a commercial PV system. Also, we're going to be looking at the new Snap and Rack Ultra Rail as being used for commercial projects. That is being introduced and rolled out in quantities starting in July and rolling into August. Commercial ground racking solutions, and we're also going to consider the inverter placement for those and looking at some examples. And finally, if we have time, we'll be looking at some of the tax credits that you should be considering when talking about these projects with your customers. If we have time, we'll go over an example of calculating those credits and looking at especially the macros depreciation. So to begin with, initially when we look at 72 cell modules versus 60 cell modules, in the past it's been thought that 72 cell modules are ideal for commercial projects and 60 cell modules are more suited for residential. But there are some limitations with the 72 cell modules. So the tariff that was announced last year, and it put great risk and uncertainty on solar module supplies. And we really saw a lot of limitations and availability on 72 cell panels. Manufacturers were kind of hesitant to bring those in to the States. We also saw some module hoarding as people were not sure of what the tariff impact was going to be on their projects. So we definitely saw that projects with uncertain timelines, people who were banking on stocked 60 cell modules that people had in quantities, definitely had easier sourcing of modules than trying to source the 72 cell equivalents. Oftentimes we also see that since they are stocked modules, 60 cell modules often have a lower cost per watt than the equivalent 72 cell modules. Minimum order quantities often are applied for these orders, either in full pallets or container quantities, and they're really only suited with those types of considerations in mind for the larger projects. For a medium or smaller commercial installation, the 60-cell modules definitely have a cost advantage there and a delivery advantage. Also, we see that the module power densities are typically higher with 60-cell modules. We believe the manufacturers keep their better cells segregated for use in the 60-cell residential line, and basically use the other cells in the 72-cell panels. We've also seen a trend that 72-cell panels, if you're using ballasted racking or racking that supports the panels on the short side mounting, they may be restricted in areas with heavy snow loads, or have to add additional supports or penetrations or alpine brackets or some other means of supporting the modules in the center for these applications. A smaller concern, but still there, is that the 72-cell module panels are often thicker, and so the modules could be heavier per watt, making them more difficult to maneuver and position in place. So 72-cell panels are generally suited for flat roof operations or ground mounts. Any type of a pitched roof, whereas you need two people to handle a 72-cell module safely, that could be a restriction and sometimes could increase your labor costs as you're installing these modules on a roof. Another minor concern, but we've come across this once or twice, whereas if the modules are visible on a commercial project like a hotel or such, being that most 60-cell modules are black frame, sometimes with the optional black backsheet, these can have more aesthetic options. 72-cell modules generally are restricted to the silver frame and the white backsheet. So you guys can see the table below comparing the average power densities, and you can see that the 72-cell modules are generally about 16 watts per square foot. So the way I calculated that was taking the number of cells and the watts in the panel and figuring out the square footage of your average typical module there. But you can definitely see that the 60-cell modules generally can be equivalent or superior to the 72 cells in actually getting watts up on the roof. In some projects, we're surprised, but some of the premium modules are very constrained roofs. People have been using some of the high-end premium modules like the LG 335 and the 350 for some projects where getting the most watts up on the roof is a concern for the customer. So some commercial PV design trends, we are definitely still seeing customers and installers using much higher DC to AC inverter load ratios. So in the past, when modules were very expensive, it was very common to try to keep that where we didn't see any clipping of the inverters. So all the watts that the PV modules could generate directly equate and get transformed in the inverters to usable kilowatts and kilowatt hours that the industry or the homeowner could utilize. Now we're really seeing that inverters are being designed for and even encouraged to go to higher DC to AC ratios. Most common in residential now, we're generally seeing a lot of people pushing 130, 135. Some new inverters, the Fronius-Simon inverters have recently been certified for much higher DC to AC ratios. The SMA Core 1 specifically is advertised as being able to handle 150 DC to AC easily. This is especially the case if you are using racking that and carefully design either the MPPTs or the inputs and have modules facing at different planes, or using an east-west racking. If you can have half the modules facing east and half the modules facing west, the higher DC to AC ratios are definitely applicable here. And in that case there, you probably would not see much clipping at all. If clipping does result, typically it's only a couple hours during the year, and you can calculate those clipping results using some of the more advanced planning tools. The helioscope is one of those from Folsom Labs, if you have access to that, or PVSys could calculate the loss. And typically, if you can keep that reasonable and consider how many inverters you may save on a larger installation, it's much better to do that. So anyway, in this case here, your inverters, even if you are loading them to higher output, you're generating more kilowatt hours for the customer each year. because the inverters will reach their peak output earlier in the day. You have minimal clipping during very high irradiance that's allowed, and the inverters are not damaged by the high loading. You result in using very fewer inverters at the site, lower cost to purchase and deliver these inverters, install and maintain, service, less warranties to buy, less inverters to hook up to monitoring and look at, and it results in much lower cost per generated kilowatt hour for your PV system. Also, still seeing newer commercial installers. They're used to doing residential mounts or ground mounts, and they want to tilt extremely high angles to try to capture every single watt that the module possibly could capture, but not realizing that that gets rid of a lot of benefits for larger installs on commercial roofs. So higher tilt angles, it's been common in the past to try to tilt at your latitude to maximize your production throughout the year. But as module prices have dropped, that's less the case. So higher tilt angles, you have to leave much larger inner row spacing to prevent shading. Since the majority of our net metered solar production, whereas most of the country is still in net metered, occurs during the summer months, the lower tilt angles actually could benefit there. And since we can get more modules with the smaller inner row shading, we can definitely increase the size of the arrays and produce more power. So lower tilt angles do allow the PV arrays higher net energy production over the year. And if you consider an east-west racking solution, we almost completely eliminate all inner row shading and get the maximum density of modules up on the roof. This also results in much lower cost racking and lower ballasting requirements, which also can be a concern. Rapid shutdown, yes. So as we've developed and moved from NEC 2014, as states are starting to adopt NEC 2017, so NEC 2014, we had a 10-foot boundary around the array that was considered for uncontrolled conductors. So we had to control those conductors outside that 10-foot boundary. And that generally prevented commercial inverters from being located on the wall outside, which was typical near the utility point of interconnection. NEC 2017 code, that boundary shrinks to only 1 foot. And also it has language for the maximum voltage allowed inside the array. So that was put on hold until January 1st of 2019, which is right around the corner. The module level requirement anyway. Sorry, the interior array voltage requirement. So it's different from the module, specific module requirements. But anyway, the voltage within the array now, after January 1st, this clause comes into effect. All the voltage inside the array has to be under 80 volts in 30 seconds as well. So in essence, this requires rapid shutdown at the module level. Even dual optimizers with 2 panels in series can likely exceed that 80 volts so on coldest day conditions. So we want to make sure that that can be accounted for. Commercial inverters that are mounted within the roof array next to the arrays up on the roof, that was one strategy to meet rapid shutdown requirements in the past, and will be good for people still on the NEC 2014 and earlier codes. So the SMA Core 50 inverters have been extremely popular. We'll talk more about them. We've seen those being used. They're easily picked up with a little lift set up on the roof right next to the array within either the 10-foot or the 1-foot boundary, and they meet those rapid shutdown requirements. Solar edge inverters have also been very popular for both residential and commercial systems. And since the optimizers deactivate the power when the inverters enter a rapid shutdown or an emergency situation, they qualify as well and have been very popular. Other inverters, including Fronius, the SIMOs, the SMA Tri-Power series, other inverters, special ballasting racks can be used to mount these inverters, or some people come up with their own racking and locate the inverters next to the PV array. Special comment about that, be sure that you install those inverters per your manufacturer's recommendations. We did see some inverters where, being that they are now at a tilt and they're not mounted vertically, that special care has to be taken for your drip boundaries of your conduit to make sure you don't get water intrusion in those inverters. We have seen a couple inverters where some water intrusion happened in the DC combiners, and that is not good for those inverters. New for this year, the IQ series inverters from Enphase, the microinverters. So they now have a 3-phase 208 version of their Envoy IQ. And actually, it's just a 3-phase, so don't want to exclude the 240 Delta people out there for some of those agricultural 3-phase systems, if they have those, or the 3-phase Delta with the high leg stingers. But they have 3-phase versions of their IQ Envoys and aggregators. And since the microinverters auto-detect the voltage and phase, installing them with those products will allow them to use for 3-phase once again. So we kind of had Enphase fall off of commercial for a while as they were a little bit on the higher cost and other solutions were out there, but we see that especially now that we're moving into a rapid shutdown environment on the module level, that Enphase will again be a major player in commercial. So continuing on rapid shutdown considerations. So after January 1st, what do we do? So SMA has partnered with Tigo and has branded their optimizers and gateways to be used on both residential and commercial systems. We haven't seen a lot of detail on this yet, but Tigo has their TS4-F fire safety MLPE in addition to their other Power Plus optimizers. And the advantage there is that since it is signaling over SunSpec, we don't require the gateway and the Cloud Connect. And this is strictly a fire safety rapid shutdown device. So we're not getting optimization with that. We're not getting monitoring with that optimizer, but we'll meet rapid shutdown after January 1st, 2019, if combined with an SMA system, or if you're using the Tigo system with other inverters, that will be for other inverter brands. SolarEdge, we have the option to move to single panel optimizers. The P320, P370, P400, P505, all of those optimizers can be used for commercial. It will be a higher cost since we're using one optimizer per panel in this case, whereas in the past we were used to using one optimizer for 2 panels. We'll have a higher optimizer cost. Or we can switch to the P800P optimizer, and that has 2 inputs for 2 separate panels. So the array voltage is not raised by 2 panels in series anymore, as was typical for like the P700 or P730. So each panel has its own input, therefore it meets rapid shutdown there. So we're actually highly anticipating that P800P being a pretty good way to meet rapid shutdown. We mentioned the IQ series of microinverters. And then also, Fronius specifically is going this route. They're recommending solar modules that have the maximum junction boxes installed. Those are SunSpec compliant and would talk to inverters that conform with that protocol and communicate rapid shutdown signaling over the existing array wires. So traditional string inverters, they're going to be very much limited now to be using on carports or ground mount PV arrays where NEC 2017 and 2014 does not apply. Although we have seen 1 or 2 jurisdictions specifically want rapid shutdown universally. So please be careful about that and check with your jurisdiction before you get caught installing a very expensive rapid shutdown system aftermarket to meet rapid shutdown if your jurisdiction is requiring that for ground mounts and carports. Here is the updated map as of April 1st, 2018. All of the gray states that you see there are on the NEC 2017 code cycle, and several states are in the process of adopting 2017. So we'll see that in a minute. Many states are still on 2014 right now currently, and we actually probably will see a big uptick in commercial rolling into the second half of the year. So there will be a definite cost savings for your installers if we get systems installed prior to January 1st, because we will be under older rapid shutdown, not the module level. In addition, as a reminder, your tax credit for commercial projects drops also, so you get a double hit as of January 1st, 2019. So please pay attention to that, and if we can get projects in this year, there's definitely an advantage to that. So our next slide shows states that are currently transitioning in their code cycles. In particular, we have Alaska, Connecticut, Florida, Hawaii, Kentucky, Michigan, Montana, North Carolina, Rhode Island, South Carolina, Tennessee, Utah, and Wisconsin transitioning to the NEC 2017 code cycles. So if you look at the NEC adoption maps, they will have the dates when each individual state is expected to adopt those. But please pay attention to all those states in addition to the ones currently on the 2017 code cycle, because we're going to have module level rapid shutdown in effect as of January 1st. So this has been one of our star performers this year, is the new SMA Core 1 50 kW inverter. It's about the size of a college dorm fridge that you send with your kids to college. Being as a nice, compact, robust design, they completely redesigned. They went away from their tri-power inverter line that has been a mainstay of commercial installations for many years. This is a completely new design with high efficiency. They saw the problems of using an external combiner and strings coming in, and with only 2 MPPT circuits. They saw some commercial inverters and the benefits of having 3 circuits or 4 circuits. So they went with 6 circuits, 6 different MPPT circuits. These are direct plugins as well. This allows a total of 12 strings coming into the inverter. So being that it's only 2 strings per circuit, we avoid the need to individually fuse each string, since it's only 2 strings per MPPT circuit. This allows an infinite, really, design flexibility here for number of panels or subarrays or trying to meet there. In addition, these inverters have a very wide MPPT window. These things are really, really nice. They're SA compliant, so they meet California Rule 21, Hawaii Rule 14H. They will be SA Smart Grid compliant for other jurisdictions and utilities as that becomes more the norm as we potentially move away from net metering in the next couple years. Another thing that's very nice about these is that they have an integrated AC and DC disconnect. So one of the issues with mounting an inverter up on the roof is having an accessible AC disconnect within range to service the unit. And those separate AC disconnects on the tri-powers or the Fronius Simos often would add unnecessary costs to the inverter. These have an integrated AC and DC disconnect. Advertised with up to 150 DC to AC ratio, so fewer inverters up on the roof. They fit right up in the array area. They're easily lifted up in place. The holes that you see there are screw-in handles that are provided, so 2 people could pick these up and walk around them. I mean, they're not the lightest in the world, but they're definitely movable around up on the roof using the provided handles. It was an issue before hooking up commercial inverters to try to get them integrated into a computer network. Oops. Something happened. There we go. I'm sorry. These have integrated Wi-Fi access with easily configured using a smartphone or a tablet. And we've had people install, for example, ingenious long-range wireless bridges that would create a Wi-Fi network up on the roof that all these easily connect to. So we don't have to run the data wiring monitoring from inverter to inverter to inverter, daisy chain style, making integration and monitoring these very easy. Since there's fewer inverters with the larger inverter capacity, with the high DC to AC ratio, fewer inverters also bring up on the monitoring. And these are suitable for roof and carport and ground mount applications. They can sit on a little concrete pad. They can be mounted on a little plenum or a ledge or bolted to the carport racking. I mean, these things have just been brilliant. Rapid shutdown. We mentioned before that with the Tigo branded, the SMA branded Tigo Power Plus optimizers, that the new TS4-F would allow effective module level rapid shutdown. We still have inverters that can be mounted on ballast and racking. SMA inverters or the Fronius Simo inverters are still being used for medium to smaller commercial arrays. So the example shown here is the SMA with their ready rack. These are installed at the factory. This ensures good water sealing to the CU1000 combiner disconnect and the AC disconnect that is mounted on the skid. The skid folds up nice and easy onto a pallet, and then one inverter per pallet is delivered directly to your job site, all factory assembled, ready to go, lifted into place with a crane, and then your crew would install that. These come in 12 kW up to 30 kW units, and with the combiner disconnect can handle multiple strings and array sizes. They have a wide MPPT windows, and they're SA compliant for California and Hawaii. So again, if MLPEs are used to meet rapid shutdown after January 1st, we have the Tigo Power Plus system for SMA, or you could source and get the Maxim modules or other Sunspec equipped rapid shutdown device for use with Fronius Simo inverters. SolarEdge just recently announced new commercial inverters that are starting to become available. So the mainstay of the SolarEdge line, and they've taken a good percentage of both residential and commercial installations, we think mostly because of meeting rapid shutdown. And then once people install it for that, they realize that there's other benefits as well. So the mainstay has been their three-phase 208, 9, and 14 kW inverters, and also their three-phase 480-volt inverters, which used to come in the 10, 20, and 33 kW size. We're seeing less availability of the 10 and 20, and they're concentrating more on the 33s. The new large format inverters, though, have a master unit in the center, larger DC disconnect. They've done away with the display screen, and then you'll have one or two baby units or daughter units on the sides of those, which are plugged into the central unit, and that'll give you 43.2 kW size and AC capacity for three-phase 208. Or there's a version of 66 kWs, which will be one master and one slave unit in the 480-volt inverters, or 100 kW blocks, which combine two daughter units with the central one there. SolarEdge allows up to 145 DC to AC ratio. You do have to get those approved. The tool will allow you to configure up to 135, but the higher ratios, we have got those signed off. They're under warranty. They'll honor those, but they do want to take a look at those installations first. They're SA compliant and can be installed in California and Hawaii. And so we expect these inverters also to be popular, even though there might be limited availability this year. As we roll into the next year, we definitely see that as NEC 2017 comes into effect, that we're going to have an increased interest in this. As mentioned before, the single optimizers could be used on any of these inverters to meet rapid shutdown. And we also have the P800P, which is a dual optimizer with two separate inputs. So the normal dual series optimizers, where you have two panels in series, as mentioned, they may be over the 80-volt limit, or you might have trouble convincing an inspector that they're under 80 volts. So be careful there, don't get caught. But nice here is that, as with all inverters that are using MLPEs to achieve rapid shutdown, we can take these inverters off the roof, not sacrifice valuable array space, and have to really worry about inverter placement to be within 1 feet. Even your thermal breaks or your walkways could interrupt your rapid shutdown for a picky inspector. We can take these inverters off the roof, put them back down on the wall, nice shady spot, get better efficiency out of them, being that they're nice in a cool environment. Right next to the point of interconnection, take advantage of your long DC high voltage runs. So there's a big advantage in using MLPEs for rapid shutdown. So we mentioned that Enphase, with their IQ systems, we're seeing this, especially rolling into the end of this year and into the beginning of next year, that the IQ inverter should be really considered for three-phase 208 and three-phase 240 projects. It's their 6th generation microinverter, IQ6, IQ7. We actually are getting hints that the IQ8 is right around the corner as well, and we might see that maybe second quarter of next year, but it is on track for development as well. The IQ6 inverters and IQ7s, they can be used up to 350 watt modules for 60 cell modules. The IQ7 and 6 Plus, those are configured for either 60 or 72 cell modules. So if you have a higher wattage 60 cell module, or if you have a 72 cell module, then this is the microinverter that should be used. So it has a wider voltage window and a higher wattage capacity, so can be used with the larger modules. They also have recently announced their IQ7X. So in the past, Enphase and 96 cell module, aka SunPower, they never really played nice with each other, being that they were higher voltage, and SunPower did have their own integrated and integral microinverter. But with the Panasonic modules needing a microinverter, Enphase does have their IQX, which is the higher voltage range for 96 cell modules. Some of the advantages of the IQ inverters is that they went to a much reduced cost trunk cable system. So they removed the neutral wire, and if they remove the neutral wire and the grounding is through the racking anyway, the ground wire came off as well. So we went from a 4-wire system, which is a big, thick, engaged trunk cable, down to a 2-wire IQ trunk cable. So it's easier to manipulate, lower cost. You can do a lot of really nice things with that cable now. 25-year warranty for all products in the United States. Might be lower warranty in overseas, but here in the United States, it's 25-year warranty. And it's a really nice plug-and-play system. So they have a rooftop combiner system they're calling the aggregator. This is a fused rooftop combiner that'll allow 3 AC branch circuits to come in, and then leaving that is one common L1 and L2 line. In the case of the 3-phase, it would be L1, L2, L3 coming down. So you can basically get 60 amp circuit off of the aggregator with 3 20 amp circuits plugged into it. Infinite flexibility, so you can plug the middle of the cable in and have modules on either side. You really have to play with the IQ system. Look at some of the examples they have on their design sheets and see the infinite possibilities that you can have for use with the Q cable, with different field wireable connectors you can plug in, and with the aggregator. So they have a communications gateway called their Envoy IQ. And up until this point, just until very recently, it was limited to single-phase residential or single-phase commercial projects 12240. But they now have an IQ that will talk to all the microinverters on the roof that is applicable for 3-phase, both 240 and 208 volts. We mentioned the high CEC efficiency of 97.5, and also this meeting rapid shutdown requirements at the module level. These have been UL 1741 SA compliant for California, Hawaii. Excuse me. And really, we should start considering this again for smaller projects, broken up arrays, modules requiring a lot of little walkways, or broken up by AC units. We're thinking that this is going to be a star performer at the middle to the end of this year and rolling into 2019. Okay, commercial rooftop racking. So flat roofs are ideal for use in ballasted racking systems. Ballasted systems are quick to design, easy to install. We have the tool for one of those systems that we can, usually if we have all the inputs, we can configure a system quite quickly and get you something fairly easily and quickly to your customer for feedback. There's fewer materials that are needed typically than a rail-based system. And since we're not doing any roof penetrations, we don't have to have a roofer come up and reseal that. If there was a problem with the roof, we can remove a portion of the array. Easier servicing of the roof if there is any issues, not caused by you, of course. And much less roof warranty issues where you're talking with the building owner who's talking with the roofer, trying to figure out who's responsible for the roof warranty. Some of the limitations, though, in California and other seismic areas, these places may actually still require some penetrations for seismic. We have some really great offerings with the ChemLink E-curves, where we can offer penetrations that are 25-year warranty, Josh, on the E-curves? 20-year.
20-year.
20-year if they do the 10-year check, right?
Yes.
Okay. So the ChemLink E-curves is an excellent solution to seal penetrations on most roofs. Also, we've had great experience recommending Anchor products or OMG Power Grip Plus for the seismic anchors for TPO and EPDM and other roof surfaces. Back to limitations of ballasted systems. Once you get above 5 degrees on the slope, the sliding forces tend to dominate more than the uplift. So sliding forces, we've been asked to try to design systems up to 10 degrees. We do occasionally see those get approved, but at times it's just better off going with a penetrating system at that point. Once we get higher and higher roof surfaces, the wind loads tend to pick up quite rapidly. So they're not really suitable for systems and roofs that are over 50 feet high. The wind exposure, which is one reason for the 50-foot high building, it's probably the tallest building within, a couple miles. It drives the ballasting and tilt module limitations. Higher tilts need more ballasting, need more penetrations. Lower tilts need less. So be sure to ask that we have the correct information, that all the wind loads are correctly identified, the exposure categories are identified, the building risk factors are correct. We see a lot of people using online tools to get a ballasting solution from other systems, those going through the design stage and then getting caught up in permitting or with the building limitations. And we want to do a great job for you guys and recommend the right solution that's not going to give you problems down the road. So case in point, in Puerto Rico, systems that we've designed and seen designed with Aero Compact that went through the design process, were designed for the hurricane force winds. Those were unaffected by the hurricane. Other systems, they're not on the roof anymore. So let's get all the correct information and make sure that we use the correct wind loads and exposure categories, even if it does drive some penetrations, even if it does drive slightly higher costs. So just quickly comparing penetrating racking versus ballasted racking. Penetrating racking, of course, you have roof penetrations into the structure that anchors the array. Ballasted racking uses a combination of ballasting and maybe selective penetrations. With a penetrating array, we have to make sure that we seal them properly. With ballasting, we don't have to worry about that since we're typically not penetrating the roof unless it's seismic or high wind loads. Higher tilt angles we can get on the penetrating racking. If you have a very small array on a very big building and you do want to tilt it at 25, 30 degrees, that's more of a penetrating racking example. Ballasting racking, typically, we want to keep that to 10 degrees or less. There are some options out there for 15 and 20 degrees, but for the reasons we mentioned, that typically is not the way we want to go. So a penetrating racking system can be installed on either pitched or flat roofs. As we mentioned, 5 degrees is the limit for most ballasted racking systems. The lower array weight on a penetrating system results in less roof dead load, so it's better for older buildings or buildings that are not as structurally sound. And the higher roof loading due to ballasting weight, we can reduce that on a ballasted system if we add some penetrations. On a penetrating racking, it's a pain to service the roof. I mean, you got to remove the racking, the anchors, everything, get down to the structure, potentially to service that. Pay for the array to be removed, stored somewhere, and then basically you're reinstalling the array. On a ballasted racking system, we can easily service a small portion of the array without removing it entirely there. Also with penetrating racking, since you have the rail for the wires and channels, attaching the MLPEs as we move into January 1st, 2019, you have tons of options for wire management and attachment of MLPEs. Ballasted racking, we typically have to attach those to the modules. For hybrid systems, so here we're using mostly a ballasted system, but selectively applying roof anchors in key points, keeping it from sliding. We can use a higher friction coefficient, resulting in lower ballasting array. And then we really concentrate on sealing those few key penetration points really well, either contacting the roof of record and helping us using the Chemlink E curves, or using the aforementioned anchor products or OMG attachment points and installing them per manufacturer specifications. So if these penetrations are located correctly, we prevent the sliding, and as we said, we can further reduce ballasting requirements. We just have to optimize and look at the trade-offs between penetrating and ballasting systems. So the fewer penetrations need more ballasting, but we can get rid of some ballasting if there is a load to hit. When you submit intake forms to us, if there is a maximum dead load that's allowed, please identify that ahead of time, and we can put that right into the tool. If you say the roof can hold 4 PSF dead load, that can be accounted for very easily, and we'll just recommend the key penetrations that are needed. So moving on. So here's the Aero Compact ballasted racking. We've had this for offering for about the past 2 years, and it's been very successful. So it's a landscape formatted array, and it connects directly to the module frames with no rails. They offer it in a 5, 10, and 15 degree south facing tilt, and the 5 degree also has 2 spacing options. So we can really maximize the roof surface, as I'll go over a little bit later, using the 5 degree south with the short spacing. To further maximize it, they have an east-west tilt, which almost completely eliminates the inner row shading. 25-year warranty, wind tunnel tested up to 150 miles an hour, UL 1703 compliant with integrated grounding. And of course, we mentioned that we have the Aero Tool design software. Also, we're getting a lot of people that are taking advantage of Aero Compact having wet stamp availability in all 50 states. It does take a little bit of time. There is an additional cost for that, but we let you talk directly to Aero Compact to get those, so we don't get in the way of those wet stamps when they are needed to move things along in the permitting process. There is a light version available for Aero Tool. If you'd like to sign up for that, we can get you information, and you can put in some of these arrays and play with the tool yourself. There are pre-attached rubber pads. Sorry, these are not pre-attached anymore. I have to edit that. Those are separate felt pads that support there. So they go under the feet, they go under the ballast trays. And of course, we mentioned there's support for penetrations to lower the ballasting, or if seismic requirements are required. We installed, Aero Compact installed over 100 megawatts of systems in 2016 in the USA on this system. Are we doing on time? Yeah, okay. So here's a quick example of the density of the arrays with the various tilt angles. So considering Aero Compact 15 degrees south versus the 5 degrees south versus the east-west. So this is a building that I chose in Sacramento, and PV watt estimates were used for that calculation using the SolarEdge design tool. And of course, your energy production will vary by location, but this is just for example purposes only. So on the same building, if we go with the 15 degrees south, we fit 1,245 standard 60 cell modules. That array over the course of the year produced 348 kilowatt, 569 megawatt hours. So 350 kilowatts was deployed there in this example. With the 5 degrees south, we were able to get 400 kW, almost 50 kW more, and over the course of the year, we delivered a 15% higher, 9% higher kilowatt hour production at 620 megawatt hours. If we switch to the east-west spacing on the same roof surface, same area, we got an extra almost 50 kW on the roof, and that resulted in 673 megawatt hours produced for the business owner, and that was an 18% increase over the 15 degree south example. Oops, there we go. And this is, I think, most important here. The 15 degree south, we added 3.2 PSF dead load, and you needed 3,200, almost 3,300 ballast blocks to support those modules. If we went to the 10 degree east-west, we only needed 910 ballast blocks to secure almost 100 kW more in modules for that racking system. So that only added 2.35 PSF dead load. What we usually see is that the ballasting is only around the outside of the array. There's no place for the wind to get up under the modules and push them around. So the east-west option is really a nice way to go if you're considering dead load or system cost. Without the need for the wind deflectors or the wind deflectors / ballast trays, the cost really gets driven down. We've seen some systems, some large systems, be as low as 9–10 cents a kilowatt hour, 9 cents a watt for materials for the east-west. Also, if we're looking to lower cost on commercial systems, we have a new offering from Snap & Rack this year called their Ultra Rail. And somewhat limited availability. It's been so popular, we've had in trouble deploying it under traditional distribution, but we're starting to see that some stockpiles and manufacturing catch up. We're starting to ship now to our traditional partners. It's a lightweight rail, so they've really taken a lot of the meat out of that rail, lowered the aluminum content. They've removed the bottom channel, and now a specialized L-foot that will attach to any of their standard roof attachments will grab onto the bottom of the rail. And they basically looked at where most systems were installed. They tried to maintain a reasonable attachment spacing, and they optimized it for states to light to moderate snow loads and wind loads. And it is the largest rail span capability, so it's of any light rail solution. We always still have Series 100 racking if we have a penetrating racking requirement for heavier snow and wind loads, or if you really want to maximize the attachment spacing. But we really see a lot of cost being driven out using the Ultra Rail. Advantage here is it uses all the standard Snap & Rack mid and end clamps. All the roof attachments stay the same. It's just the rail and the attachment L-foot is changing. It is a low profile and still maintains the open channel for room for wire management. Your rails snap into the mounts attached to the roof attachments. And they've added some new wire management too, since it is additional larger junction boxes. They have a new smart clip, which is a frame attachment for modules for MLPEs that you'll need for for systems going into next year. And also new smart clips and wire saver features, which should really help with any racking system that you might be using. We talked about large ground mount arrays in the past, and I wanted to reiterate that a lot of times for medium and smaller systems, we were asking about pile-driven systems or specialized large-scale racking systems just because it has a commercial tag on it. We've done Snap & Rack and very competitively bid systems up to 200 kW using Snap & Rack. It's a system that's easy to understand, easy to permit. Pile-driven systems usually require special engineering studies, and this quickly adds it up in the dollars and delays your projects due to engineering studies. And those delays, especially as we get to the end of this year and you're trying to get projects in before January 1st, consider Snap & Rack for your larger ground mount arrays. We're seeing cost of materials 15 to 17 cents. Please talk to us if you have a larger project, and we'll be sure to try to work with you on that. Just an example of your Series 200 ground mount. Yeah, that's a nice picture. So we talked about it optimized for small and medium-sized ground mount arrays in both commercial and residential. It is optimized for a 4-module high landscape orientation. And as with the previous discussion with the ballast racking for commercial, consider using a lower tilt. It'll save you pier depth. It'll save you number of penetrations into the ground, the amount of bracing you need. If we keep that depth, that tilt to a reasonable 15 degrees in most of the United States, you're going to see a lower cost commercial project and less inter-row spacing needed. So we also have an offering from Aero Compact. This is an alternative to the penetrating system, but they have a ballasted racking system for the ground. We're really seeing this take off. Very quick install times. No need to dig holes and set piles for concrete. No large machinery needed. No pile driven. No engineering study needed for soil. No frost heave. Special considerations if you have frost line where you have trying to achieve a depth. So it installs as a completely ballasted system. They also have optional screw anchors if needed, and we've seen a lot of people using those as well. So we can ship up to 1 megawatt of racking on a single truckload for a site. And if there's a brownfield or a landfill that can't be dug into, it's really nice there. We didn't think this would be a residential offering, but we're doing a lot of small residential systems with this as well. There's a ground covering, a fleece mesh that can also be provided that'll help prevent vegetation growth. And we see this in the 15, 20, and 25 degree tilt offering, or with nice module density, there's a 10 degree east-west. Notice that these have higher legs than the roof mount, and in places with very high wind loading, we actually can do the roof mount on the ground as well. So that is an additional option, is putting the roof mount ballasting right on the ground. Although since it's lower to the ground, we have to really be careful about the vegetation growth. How am I doing? Oh, okay, we're coming okay. Inverter locations. So for ground mount arrays, with the snap and rack or the pile driven systems, we can put the inverters right behind the modules on the racking. Nice sheltered, shaded area for the inverters, and usually the NEMA 4 enclosures, as exemplified by the SIMO inverters. Other inverters might have NEMA 3R. You might have to put a back on those to make sure you don't have water intrusion. But they allow outdoor mounting very nicely. So this very much simplifies the array wiring and installation of these systems. For three-phase, a lot of times you want to take the inverters, if it was a single phase, you're limited to 600 volts on residential, putting the inverters near the point of interconnection on the wall. But with the three-phase 480 volt, there's not a real big difference in voltage drop between 1000 volt DC wiring and three-phase 480 volt. Do your voltage calculations, make sure we have appropriate size wires for those. But you have to weigh the benefit of locating the inverters near the point of connection in the group for servicing and maintenance, or locating the inverters behind the racking on a pile-driven or a pier-driven system. So mounting the inverters on the array, we avoid the extra DC disconnects that some jurisdictions may require for that underground wiring. But a central inverter location near the point of connection could share a common AC sub-panel that could serve as AC disconnect. So remember the consideration that we had with the tri-power on the ballast racking system. Your jurisdiction may require an AC disconnect if you place your inverters under the racking. So a lot of cost-benefit analysis to be done there. Monitoring definitely is easier if the inverters are centralized in a bank. So yeah, we got time for this one. Okay. So as we roll into the end of the year, we still have a 30% federal tax credit on materials and installations of commercial and residential systems to the end of this year. My notes say through 2019. It expires January 1st, right? It drops January 1st.
Yes. Okay.
So it's actually through the end of 2018. That slide should read, not through 2019. So that's a mistake on my part there. Then January 1st, 2020, we dropped 26% for commercial, 22% in 2021, and then in 2020, there's no expiration going forward, but it drops 10%. So there is an advantage, although it's only a 4%. If we get the projects in this year, it's a 4% drop going if your projects drag on into next year. However, one thing that's often overlooked for commercial systems is applying and having the customer calculate his modified accelerated cost recovery, or MACRAS depreciation, on his solar assets. There's a 5-year accelerated depreciation that he can apply over those 5 years on the system. this represents possibly an additional tax savings for your customer of up to 10% of the system cost. The Protecting Americans from Tax Hikes Act of 2015 included an extension for this bonus depreciation applied to year one. So the companies can elect to have this initial depreciation bonus up front, and the remainder is depreciated under normal macro recovery period. So that does drop going forward. So please, not a tax advisor, not a tax attorney, just be sure that you consider that and you consult a tax attorney or advisor or an accountant to figure out what your customer is applicable to. But it could represent a substantial savings. So this was a calculation I did last year. So considering the depreciation, 85% of the net PV asset costs are eligible for depreciation according to IRS Form 4562. I'm not a tax expert, so. The depreciation schedule for year 1 to 6 goes 20%, 32%, 19, then 11.52. This determines the deduction that the system owner can take. His actual value of this credit really depends on what his corporate tax rate is. He has to be paying taxes to take a tax credit. So one problem we've seen with recommending very large systems with very large tax credits is that the guy has to wait 3 or 4 or 5 years to fully get theirs, especially if he's not running a profit on his business. So be careful about that. So let's take, for example, a 40 kW PV array with a $100,000 total system cost and a 30% corporate tax rate. Year 1, of course, he gets his 30% tax credit, so he gets $30,000 tax credit. Then the tax savings resulting from calculating the depreciation goes as following on the table there. So overall, the net PV system cost over his 6-year period, after you consider both the ITC and MACRS depreciation, we started with a system cost of $100,000. He got a 30% tax credit for $30,000. Over the 5-year period, we totaled $24,000 in MACRS depreciating tax credits. So the total net system price to the customer over the 5 years is almost half when the tax credits are considered. So his net install price ended up being $45,800. So this is very critical when you're competing against other commercial installers that you recommend that they do that, because other guys are definitely taking to consider that. This example assumed that there was a $2.50 per watt installed system cost. We definitely know you guys are doing better out there, but regional variations for cost varies, and it was just an example that I used to calculate the tax credits. Please don't use that $100,000 for 40 kW system be used as your example and setting your pricing based upon that. That was just for the calculation of the tax credits. Have any questions? I do have some photographs to show of the some of the racking systems. We can open up the questions. We have a little bit of time.
Yeah, we have a little bit of time here. So just quickly here, I'd like to go ahead and thank you, Glenn. We are a little bit late here on the questions, so we want to be mindful of your time. So we'll go ahead. If you do have any questions, go ahead and submit those to the question pane located on your control panel, and we will try to answer as many questions as possible. You can always exit the webinar at any time during or following the question and answer session. There'll be a survey that will pop up in a new window once the webinar ends. Give us your feedback on the survey, and I will send you the presentation. We did cover a lot today, so be sure to go ahead and do that survey so we can get you that